So the topic, excuse me, of this video is on rational exponents, and really what is meant by rational is a fraction. So we're going to be looking at fraction exponents and determining what their impact is or what they mean. Okay, and this, I believe, is the first time you've probably seen this before. So we're going to really take a look at these first two first. So 16 to the 1/2 and 216 to the 1/3. So if you type those in to Desmos or a calculator of some sort, you can type it into a regular calculator as well. When I type in 16 to the 1/2, I get the answer of, of 4. And when I type in 216 and then to the power of 1/3, I get the answer is 6. And so I kind of want to play off of that information to start and think about, okay, well, wait, what could I have done to 16 to get to 4, right? What are my options? So I could have done 16 divided by 4. That would give me 4. And I also could do the square root of 16, and that gives me 4. So, okay, those are some options, right? And when I think about what could have done to 216 to get to 6, well, do either of these options help me out, right? So if I'm trying to get to from 216, if I divide it by 4, that is not it. It's 54. So that this whole divide thing kind of goes away, right? And when I take the square root of 216, which I don't know what that is off the top of my head, but when I take the square root of 216, I get like 14 something. So the square root thing doesn't kind of have any mention here either. However, there is something different. They weren't raised to the same power, right? And so when you think about a square root, you think about it being, what times the same thing, x times x gives me the number. Well, this one has a 3. And then it got me thinking, well, wait a second. If I take the cube root of this, so I'm going to go to, let's see here, where's my cube root button? Right here. If I go, let's try that on a new blank, so sorry. If I go and get the cube root of 216, I end up with 6. All right? And so this denominator is pretty powerful because it's kind of talking about roots here. So square root of 16 is 4. The cube root of 216 is 6. So just those first two get me thinking, all right, I kind of get the denominator, but then 3 and 4 come in and you're like, wait a second, what's a numerator then? What does that do? So let's see if we can do this the same way. So if we know that the denominator is the root, then I'm going to take the cube root of 8. So if I think about my cube root, so let me bring that button back here. So the cube root of 8 is 2, which makes sense. 2 times itself 3 times is 8. So the question is, well, I guess we should have gone back and said, well, what is the actual answer here so we can figure out what's happening. So 8 to the 2/3 power is 4. So our goal is 4, right? So we know the answer is 4. We know that the denominator is the root. So what could be happening with the numerator? Well, again, we have two choices. We can either times by 2 and get 4, or we can square 2 and get 4. So let's use the second question as a way to figure out what's happening. So let's first do 81 to the 3/4. 81 to the 3/4 power is 27. So my goal here is to get 27. So the first thing I'm going to do is use what I know, which is I'm going to take the 4th root of 81. So the 4th root of 81 is 3. So now, how can I get to 3? Or how can I get to 27? Well, I'm not going to multiply it, so that's out. So the last thing that leaves me with is an exponent, right? And so we used 2 here because it matched the numerator. So if I use the same thing, I'm going to try to raise it to the 3rd. And when you do that, you get 27. Okay, So essentially, we can get these same answers that the calculator is telling us. So yes, we can type in 8 to the 2/3 and it's going to tell us what it is, but we could also get it by roots and by powers. Remember, the root is coming from the denominator, and the power is coming from the numerator. Okay? So let's think about this for a second. So again, when you see a denominator here, when you see the 3, you know the root, right? So maybe I should write it like that. Root, power over root, okay? So I'm going to take the 3rd root of 27, and when you put that into a calculator, I'm going to stop slipping back and forth, but when you put that back in the calculator, you get 3. So you're pretty much saying 3 to what power is 81? So in my mind, I'm kind of thinking of how many times do I have to multiply 3 by itself to get 81, and that answer is 4. So I just found the power. I knew the root, I didn't know the power. So try this one on your own. Push pause, push play when you want to see the answer, but see how you do. See if you can figure out what is the power here after you use the root. So square root of 4 is 2. So we're asking ourselves 2 to what power is 32? And that power is 5. So down here, we are now missing the root, right? We're missing the root. So we know that there's some kind of root of 125. That gets us here. Whatever this number is, we square it and we get 25. And I'm getting the square from that numerator, right? Well, I can work backwards. What squared is 25? That's 5, right? And so 5 is what root of 125? That's 3. So the root here is 3. There's a typo on this page. This is supposed to be 64. I apologize. So we know, in this case, that 8 is a number to the first power. Well, that one's pretty clear. That's 8. And so what root of 64 is equal to 8? That's 2, right? I need to take the square root. Square root is 2. So in this case, what's the fraction power to get to 8? Well, if we think about this, so the only way you can get to 8 is by using 2. All right? So 2 times 2 times 2 is 8. You with me? So no matter what, our power, if we're thinking power over root, our power is 3. So we have to go backwards and think, well, what root can we take of this to get to 16? Well, in my mind, if we need to get back to 2, we could do it this way. We could divide by 2 so many times. Oops. 4 divided by 2. That's 2. There it is, right? So let's see here. We divided, it would be 2 to the 1, 2, 3. There's 4 of them, right? So, and you could check this. The 4th root of 16 is 2. So 3/4. So last but not least, when you're trying to figure out this one, these challenge ones here, you could do, how could I get to 27? The only way you could do that is 3 times 3 times 3. So I need to get 243 back to 3. So in your calculator, you can be like, well, 3 to the first is 3. 3 squared is 9. 3 cubed, 27. 3 to the fourth, 81. I mean, you could be typing this in. 3 to the fifth, 243. Bingo, there it is, right? So we know our root to get back to 3 is 5, and our power is 3, so 5/3, all right? So essentially, you're over your generalized rule. So x to the mn, where m is the power and n is the root, okay? So that's kind of important as you move forward. And then there's all kinds of examples where it's asking you to rewrite it and then calculate. So in this case, if I've got the root, there's no power here. This would be, this would be 128 to the 1/7, right? Or 125 to the 2/3. You with me? And then you'd plug those in your calculator or try to figure them out. Same thing down here. I just have the third root of 125, or I have the square root of 4 to the third. So rewriting those just to kind of figure that out. All right? If you have any questions, let me know.